Well, good afternoon, everyone. Thank you so much for having me here at Strata. My name is Eric Frankel. I am the CEO and co-founder of the company. In terms of giving you some background, I think it's really cool to kind of just really fill in where MemSQL was 3 years ago. We went to Strata in 2012. We had just recently founded the company. We went to the startup showcase. And for us, that was our first sort of experience with Strata. We won first place. That was always a good sort of sign. And we went back in 2013 just to kind of get more exposure. And we're really excited to be here and being a sponsor in full as a Zettabyte sponsor this year in 2013. To tell a little bit about the company, it's a little under 40 employees. We recently have just crossed a little under $50 million in funding into the firm. And that's just a tremendous sort of response to a lot of the adoption that we're seeing with the technology. About myself, my co-founder and I were both engineers at Facebook, and we saw some really interesting big data problems being solved about 3 to 5 years in advance. So we left Facebook pre-IPO in early 2011 to start the company, and we went into stealth mode and started working on some really, really cool technology. We'll be able to share a little bit about that today and some new developments that we're very excited about. MemSQL 3.0, it has a new engine in it. And we'll actually be hearing from a customer about how they're using MemSQL 3.0 in production. We've always thought that a database should be simple to use. It's in our titles, in our tagline. And we saw, like I said, some really cool, interesting things at Facebook that gave us a lot of ideas about what we should be doing. So we created MemSQL to be fast, easy to use, and effectively there to give you immediate access to your real-time and historical data. To encapsulate what we are at a high level, MemSQL is a in-memory transactional database that scales on commodity hardware. Each of those things is really important, and they get so powerful in aggregate when you combine them together. The in-memory, as you will talk on about real-time, is so important as you consume a lot of data. The SQL is important because it means that anyone can use it. And the scale-out is important because it ultimately saves you money. Facebook was able to get to this great scale by using a lot of commodity hardware together. And it's really when you have the intelligence layer at the software tier to connect all of those systems that you actually get all that power and performance. So what you'll hear about today is actually how you yourself can actually bring Facebook-style analysis to your organization and business units. So the talk about today is why is it so difficult to combine real-time and historical data? Why is it so challenging? A lot of us struggle with getting access to data in the last couple days. We have to wait. Why is that? So the first element that we talk about bottlenecked on physical disks. We're waiting and waiting and waiting. And even a reasonable amount of time is hard in many cases. I've spoken with a number of folks at a conference, and it's usual to wait several hours, even days, to get data loaded into the system. It puts you as an analyst, you as a product manager, you as a data scientist behind the business and what's happening. And I think that's a number one challenge about how can you actually see what's going on with your business in the moment. How can you focus on the now? So that's the first challenge, is just getting the data in. And it comes from a multitude of sources. And that's something that is a big challenge. You just have more data to deal with. How do you actually get it into a system and actually analyze it efficiently and quickly? The other difficulty with big data is how do you store it and how do you make it accessible to you and to your end users and to your customers? I think accessibility is so important because if you can't access your big data, what's the whole point of even having it? For us, SQL was sort of the foundation. We saw what happened to Facebook when it couldn't use SQL. You just scale so quickly, and you get reduced down to a key value interface. SQL is important for engineering. Engineers can pretty much use any interface. But when you start talking about your end users, your product managers, your analysts, your engineers that build real-time dashboards, having a SQL interface really makes it a universal connector. It lets anyone actually tap into that data. So accessibility was always important. Now, when we started the company 3 years ago, SQL was very out of vogue, and I use that word deliberately. It was not cool to be working on SQL, but we've seen over the last few years a big resurgence in SQL. and how important it is. Even Google is actually building SQL into their new database systems, where a generation before, they were really sort of embracing what NoSQL could do. So when we think about accessibility, I would definitely sort of emphasize how important it is to give that data to your end users, internally to your organization, and to your end customers, whether you just expose a GUI through your web application so that they themselves can query the data. So in terms of why that's so tough, it's because there's just so much data. You typically give up SQL, you give up an interface to get data into the system. But when we talk on accessibility over the next few minutes on how important it is, just remember that SQL is in our name, and we really, really believe in it. The other difficulty in going real time is running transactional and analytical applications simultaneously is pretty darn tough. Each system is pretty much separate in your organization today, probably. You have your Oracles, your Postgres, your MySQLs, and then you have your offline or separate databases that are focused on your analytics. And what you see is that each of those is optimized for a different type of your business. Your transactions are meant to be very small, lightweight, and fast, and the SQL is pretty simple. But because of that I/O bottleneck, you're going to see sort of a focus on running the DML operations, the inserts, the updates, deletes, and the selects, rather than running the complex analytics in a separate system, so you don't actually bottleneck. So for us, being an in-memory company, we really believe how important it is to run both. How we designed our technology is to leverage the fundamental properties of memory so that you can run transactions and analytics in the same place. And I think that's a huge, huge win. It actually reduces ETL, and we'll jump into how we do that. But most of the time, just talking with a lot of you this morning, it's really sort of having to wait to get your data out of your transactional stores, your events, and then port them over into some sort of analytical system. And at that point, you're already a few hours behind. So that's not to say that it's impossible. Blending real-time events with historical data is doable today. But what problems result out of that? I would say it's fundamentally brittle infrastructure. When you look at sort of the number of systems that you need, the NoSQL stores, the caches, the grid computing systems, to say nothing of whatever standard databases that we're using, the brittle infrastructure really speaks to the fact that a lot of man hours and your own time goes into just fixing the leaks, fixing the system. It's something that detracts from your productivity because you're focused on essentially maintaining what is a very complex piece of infrastructure when you really should be focusing on things that make your business money, which is what it's all about. So building a real-time big data solution, I think, is the next frontier. If you look at how important Hadoop has been, Hadoop can store, if you think that the cost of storage is free, and it is, then Hadoop is a great place to store your data. But fundamentally, it's a batched system. And when you talk about going real time, it's pretty much the antithesis of batches. So what does it take to build a real-time big data solution? So to talk just quickly on that legacy approach, we see sort of several different operational data stores. So as I said, you might have been exploring NoSQL just to basically go faster. And that's really, really important when your business is falling over and you need to get data in somehow, some way. But you also have that complexity again. Those multiple data stores take a lot of time and effort to work with. And it basically means something very, very problematic, which is that your data then becomes siloed. You have different data in different locations. You have data in your cache, data in your NoSQL store, data in your transactional system. How do you get all of that together? And that's a huge, huge problem for everyone here. I think what MemSQL is really excited about is that I think we have an ability to actually kill ETL. And I think that is something that everyone would be happy to basically stop wasting time about how much we have to move data and shuttle it back and forth. The other thing is if you're not using a NoSQL system or you're using some sort of other approach, you're looking at very expensive appliances, mainly from the big boys like Teradata and Oracle, IBM, who will be more than happy to give you hardware to do it, but it's vertically scaled and it's very exotic and very expensive. To go back to that earlier part of the conversation about Facebook, Facebook didn't believe in that, neither does Google. Going web scale, going horizontal, uses commodity hardware, and it's tremendously powerful on TCO because you are running your hardware on-prem using commodity machines. $2,000, $3,000 a machine, and throw them all together, and suddenly you actually have more capability than you would have on a vertically scaled appliance. And the great thing about that approach is it's future-proof. As your business unit grows, you just add more machines into that cluster. Whereas with an appliance, it's a forklift upgrade every few years. So what we have here, I think, is something that I would call a Frankensteinian monster. I believe that's an Exadata appliance in the background. What you have is something that is very hard to work with, something that is clunky and stitched together. And I think there's a better way. Because at the end of the day, there's a lot of issues around latency and complexity in the conventional systems. We're all using technology that's 20 years old. It was all architected in the 70s and 80s. But here we are in the second decade of the 21st century, and we're not using modern hardware appropriately. So those slow applications and analytics, that ETL becomes a huge problem. The other thing that we see is slow development cycles. Again, I think people are the most important part of any company, and if your people are struggling to actually do their jobs, the entire company suffers. So making your engineers, your analysts, your product managers more productive and effective, it's hard to basically sync incompatible storage formats and interfaces. And at the end of the day, it's about actually getting the full value out of everyone's time. Downtime is also a big problem. If you do any sort of schema change, any sort of operation that takes a database down, now you're even further behind in many cases. You're going to be up at 2 a.m. on a Saturday because that's maybe the best time to do the downtime. So I think the whole notion of going real time means that you stay online 24/7 on your analytical systems in addition to your transaction systems. What you see here, of course, are angry customers that have to deal with these pitfalls. And these are not your external customers because they wouldn't do that. They just leave. They don't buy your product. These are your internal users that are angry because they're waiting and waiting and waiting. Their reports are taking forever. So one of the things that we wanted to do is actually really address the analytics for the internal end user. And then your external end user is equally happy at the end of the day. So now to shift gears and talk about what is MemSQL and how have we envisioned and architected the technology to really address the problems of real-time analytics. Well, it's, like I said, getting rid of ETL, it's getting rid of waiting, and delivering a unified approach. We can talk a little bit on MemSQL 3.0, which adds a column store to the engine. Up top, you see our in-memory row store. It's phenomenal for transactional analytics. You can just put tens of thousands, hundreds of thousands, even millions of events per second into the system, again, because we just use commodity hardware horizontally. It's capable of transitioning that data from memory onto a flash-optimized column store or even disk when you want to compact that data. So what you get is a single interface that gives you the ability to pull data from memory and pull data from flash or disk as you need it. And suddenly you've actually removed a huge part of your ETL problem because data can be seamlessly transferred between these two engines. What you'll see actually is a lot of vendors just selling a column store and a lot of vendors just selling a row store. But I think if you actually have a solution that encompasses both, you get something that's really powerful and can actually reduce a lot of time that you have to wait around ETL. And the important thing to emphasize again is the emphasis on commodity hardware. Scaling out horizontally, it's future-proof. It makes so much economic sense on your own budgets. It's something that has worked tremendously well for a lot of companies in the Valley and actually for us as well internally as we test our software. So I'll spend a few moments just on this particular diagram. One of the things that we recognize is that you have systems in place that are running batch analysis, and it's important to work alongside those data warehouses or Hadoop. Both of those systems are primarily batch loaded. That's how they work, that's how they operate, that's the assumptions that you have made in order to engage with those technologies. But on the left-hand side, you have real-time data that's flowing in, and it's flowing in at such a rate that your transaction stores are falling over, and you have to load even more data into your data warehouse. And that's where MemSQL comes in. So in the lower left-hand part of the graphic, you see a trend line. It starts at the red side. It's very hot data. It's your real-time data. Now, it's our belief that your most recent data is your most valuable, and that as time progresses, it gets cooler, and it becomes less important to your business. Now, that's not to say that you don't need to store 7 years of data for compliance, but it's an archive state. You don't access it all that much. And we have an ability to shuttle through that time scale very easily using our row store and our column store together. Now, when you're actually ready to put it in Hadoop or put it into your existing data warehouse, we have connectors that are optional that you can basically shuttle data in or out. But I think the important thing is turbocharging and augmenting what you do today. Meaning that if you want data in the last second or the last 10 minutes, you can use MemSQL to load that from your web properties very, very easily. Now, to get back to SQL, it's in our name and it's in this diagram. These connectors between your applications, your web properties, and your BI tools, those are all predicated on SQL connectors. So we support ODBC, we support JDBC, we support basic MySQL connectors into the system so that it's just easy to use out of the box. And of course, when you talk to your data warehouse, you're already using SQL already. It's just important to have a lingua franca that everyone can use. And this is essentially where MemSQL fits into your architecture. It's meant, like I said, to augment and turbocharge it, not to replace the data warehouse. The column store is very important, and we see sort of a real great use case that we can actually touch on with one of our customers very soon. And that's the ability to merge your real-time data with your historical data to discover trends and changes over time. A lot of in-memory systems can't store data. They're more like complex event processing, data in and data out, triggers and alerts, and that's it. But what if you wanted to find an anomaly that only manifests once a week? You need to have that data available so you can run that complex analytics. And that's something that a column store gives you very affordably. That compression means that you can store 6 times, 7 times as much data per terabyte using those compression techniques. So it's a great way to get a lot of performance operationally. And then, of course, you can still use Hadoop just to store all of the data that you ever might want. So the benefits of the MemSQL approach, it's performance, right? We're here talking about real time. It's about going faster. When you can load data quickly, it means you don't have to worry about ETL. You're not worried about batches anymore. And you're actually running analytics on your most recent data, which means it's your most relevant and your most valuable. So performance is the #1 consideration about adopting a real-time system, is because you want new insights and new analytics that you can actually decide on or recommend to your end users. Faster development is so important. If your customers, your internal customers, I should say, are really slow, their development cycles are slowing down, it puts your entire business behind. The ability just to work quickly, add an online alter table. That's a feature that we added into an earlier release of MemSQL. It sounds pretty boring, but it's so important when you can do an online schema change in production and not have any downtime. And it's those sorts of things where you really focus on rapid development, where you don't have to worry about taking a system offline or locking the database while you add a table or add a column. That's sort of the thing what we really mean about fast development. Empower your developers to do their job and really build faster. The other thing, of course, is simple, manageable infrastructure. If you add more complexity into it, it's making the problem worse, not better. So if you have fewer data stores, there's fewer locations, and in fact, you don't have silos anymore. Everyone can actually read and access the same data. Your engineers, your product managers, your analysts. So that's so important. So that is the vision that we have at MemSQL. How can we deliver a database for both real-time and historical data? If you've been able to stop by our booth, you've seen some demos. But now I'm very excited to actually bring a customer on stage to talk about how they have used MemSQL. So I'd like to introduce Gil Resch, who's the Senior Vice President of Product and Technology, and Sarah Robertson, who's the VP of Technology at CPXi. Welcome.
Thank you. Thank you, Eric. Hello, everyone. Welcome to Strata, and I'm very happy to be here with MemSQL. Where do I? Okay, so a little bit about Double Verify. We are a global digital media holding company with over a decade of experience with both consumer and brands. Basically, to make sure we are in the advertising space, we cover both advertisers and publishers. The big challenge that we are facing is we have a lot of data. We are processing between 2 and 2.5 terabytes of data a day. It's many billions of impressions. we need to keep those impression raw level for a few months. So currently we are holding them for 90 days. And this is our investment, why we were on the look for a good solution that will cover our data warehouse and all the analytics and all the needs that we had with data. So I come from before CPXi, I worked for a company and I had already experience with, again, vast amount of data and worked on columnar. And I joined CPXi about 8 months ago. Then Sarah was just in the midst of exploring all the options. And when I joined our conversation, we decided, we agreed of what are the real challenges that we need to face and to solve and how we are going to solve it. So the first challenge that we had is that we had both in-stream data. While I'm saying in-stream, it means as every advertiser, every impression happens, it happens real time. The response time needs to be, all the ad serving process from time to end needs to be within the 150 milliseconds, which leave very little time for real processing. Most of the time is going on the internet transaction, on the traffic itself. And in-stream meant that we had to count every impression in real time because a lot of decisions, what are we going to do with this impression? What ad are we going to show to the end user? And what is the effectiveness had to be in real time. So this is one way to ingest the data. The other way that we've done it, that we need to face, is that we are working with multiple ad servers. Ad servers produce a log file that creates many more data points on top of the data points that we get in real time. And those we get in files. So it's batch processes that we need to upload all the data to our data warehouse. As Eric noted, for us it was every decision that we made could be based on the last 2 minutes, the last 2 hours, or the last 2 weeks. So we had to spend the time, and we had the analysis that we had to have all this, to look at all this time in a single place. The data set that we created, again, was to do the bidding decision, which, again, it's 1 to 2 millisecond decision time within the machine had to happen. And then, of course, what I was looking is, and this is from all the historic being a product manager, is that I wanted to give a quick interface for our users, both internal and also our client, customers, everyone that uses the platform. So this was the high-level things that when I worked with Sarah, we knew that we must find a solution that will answer all of these things. While we started to look in solution and we started to work with MemSQL and see what else we are getting from this from this partnership, basically we got the icing on the cake, which was basically the SQL makes it easier to find talent, right? For me, it was I just need that developers will work through single interface, which is MemSQL. Everybody knows it. It's something which is quite simple to learn and basically will help us finding new talent. Let engineer focus on the business to make money instead of running multiple environments. One is the columnar, one is the in-memory, one is all the Hadoop and analytics. I had one single interface to work within, which in our business is very critical, and it relates also about the machines that that Eric talked about is that many times I don't know how much real data I need in memory in columnar. And being able to take data down to the disk or up to the memory is something that is a great advantage for us because we can play with it. And then we can play the cost between machines that needs in memory, or we can just write it to the disk, and then I'm open to optimize everything in regard to it. Of course, the hosting in the cloud, that was an advantage for us because all our services are on the cloud. And they manage the spikes in storage with the conversion and archiving. Again, the compression rate helped us to reduce the money that we had to pay for hardware. Anytime that we need more disk space, it's very easy to gain it. Again, we're on the cloud. It's very easy to scale. So the architecture, when we started this journey, this was very high level, the architecture that we work. So you can see on the top left side, we had one data that constantly goes. And again, it's above 100,000 events per second that constantly we need to put to ingest into our database. This went into the system, which is much more complex. And again, everything that I just talked about about the people, about the engineers that they need to do, you can see it as well. So for the solution, Sarah, would you like to take it for the solution?
Sure.
Cool.
All right, so I want to tell you guys really quick how MemSQL came into our lives as a solution. We released an advertising product that had a very small volume of traffic, and we actually had to write to the database on every single impression. We were tracking user customization information in the ads. The product became very successful, so they upped the volume, and suddenly we had to do thousands of writes per second to a database, and we're entirely hosted in Amazon. So this is actually MySQL RDS that we're writing to. It turned out that we couldn't possibly handle that volume, specifically because of writing to the disk. So all the engineers got together and started talking about how we were going to solve this problem. And of course, they started tossing around things like Memcache and RabbitMQ, and we need some cool memory queuing system. And I believed that somewhere there must be a solution that lets you write into memory with SQL, and it handles writing it to disk behind the scenes at some later time. So we started Googling, and thankfully we discovered MemSQL's product maybe 1 month after it had been released to the public. So it was very lucky and serendipitous. The other great benefit was that you can communicate with it using normal MySQL protocols. So basically what we did was download the 30-day trial, point some of our traffic at it, and then put it into production. And it just swallowed up all of that writing, and all of a sudden the volume we could handle it. Then on day 29, I had to frantically call MemSQL and get a license because we'd basically put the trial product into production. So really, if you think about doing billions of impressions a day, if you actually want to write to a database in that impression stream, it's just brutal when you have to wait for the disk. On the side, we were actually dealing with a different problem, which is our ad server partner about every 4 hours gives us these batched logs that tell us rich information about the impressions that we just served. So we can capture information like web browser, agent string, time to load, geo, all that kind of information. They would give us, revenue, CPMs, buyers, other rich information. That comes in huge amounts of gzip files, flat text data, really structured 90 columns. So of course, first we threw Hadoop at the problem and started loading all these files in there. and processing it would take minutes and even hours at times. And then MemSQL was working on their columnar solution and asked if they could, try to solve the problem that way. So we basically stood up a second cluster next to the one where we were writing in memory and started loading these files up into the columnar solution. So all of a sudden what we had was we're writing information about every impression in real time, and I'm able to query that for dashboards because it's all in memory. And on the other side, we're loading this 4-hour delayed data up into columnar, and we're able to blend both of those data sources. So for about 4 hours, you have 20 data points on every impression as fast as possible, and then as soon as the other stuff's ready, you get all 90 data points on the impression. And since it's all in one database with a MySQL connection with SQL to talk to it, all of our data analysts, the people that build dashboards and make the charts and export these reports for people to understand, we're able to just immediately combine both the real-time data and the disk data right there. I can't overemphasize the importance of using SQL. I know Eric said it a bunch of times, but being able to hire young, hungry data analysts that know SQL and don't have to worry about MapReduce or that kind of thing is just fantastic. They can basically, pivot the data, play with it, figure out how they want it, and then turn that into a repeatable query that the engineers implement on a coded dashboard, right? So it gives them a little playground to figure out what they want to do with the data. We still have some MapReduce in our lives because we have data scientists that like to use that to do modeling and predictive stuff. But for the most part, almost everything that we do that's customer-facing or product-oriented is completely driven by SQL. The other interesting thing that we did was we actually stood up one more stack of MemSQL that's pure memory, and we pointed all of our UI apps at it. Our UIs are built in Node.js, and basically we can run these aggregated queries out of the columnar row store into this other memory one, and people can pivot and filter, and it just makes a really fast user experience to have everything completely loaded into memory. So I still have a little bit of RDS in my life, but for the most part I've moved away from it almost entirely because why do I need it if I can do the same thing in memory and use MySQL connections anyways? So I kind of already talked about the solution, but basically before we had the real-time writes, we had to wait at least 4 to 5 hours to be able to know what was going on in our ecosystem. We had to wait for our partner to bundle up these logs, ship them to us, load them in Hadoop, run some MapReduce jobs, and then finally, half a day later, we'd be like, oh no, the performance is falling on this campaign. As soon as we were able to do real-time writes, it kind of changed the business. They were able to see immediately what was going on with the different campaigns that they're working on, optimizing all day long, and then on a week-over-week view, we're able to blend that with the other richer data that has, revenue and information in it, all in the same database. And basically, we just have a team of data analysts now that write SQL all day long and work with the developers to make these things permanent products for us. Yeah, that's basically it. So, thank you. So this is the new picture of the new architecture. Basically, all of the bidding information that happens behind the scenes and all the impressions coming in write immediately into memory. It's the exact same database as the one where we're loading batch logs slower as they come in into the columnar, and then we can kind of query it all at the same time. So I have some dashboards that are only looking at the in-memory row data so you can see real-time stuff as soon as it's available, some that's looking at rolled-up information out of the columnar store, and some that blends the two, and they all perform in pretty much the same speeds. You didn't really talk about the plan cache, but that's another thing that I love about MemSQL. The first time you run a query against the whole data set, it's a little slow because it's figuring out how it wants to do it, but then it caches the plan of how to run that query, and every single time after that, it's just milliseconds. So our analysts will do the first run of a query, do the second one. If the second one runs fast, then we're good to go, and we can put it in production. So it's pretty amazing. And if there's any questions, I would love to answer them. Oh, yeah, and we're hiring. So, yeah. Yes?
Is the design approach for the database design, is there a different approach?
Okay, he asked if there's a different approach to the database design. Because it's MySQL, we basically just did the same schemas that we would do for any kind of software development. There's a little bit that we had to change around columnar because you have to have primary keys that can go across a parallel distributed database, but it didn't really impact us too much. There was some thinking that we had to do around how we stored date strings, but again, we just worked really closely with the MemSQL support staff, kind of told them what we were thinking, sent them our first version of schema. They'd send us back a little bit altered schema, and then from there we could kind of run forward on it. But it was nowhere near as challenging as I found the Hadoop implementation to be when I was trying to make schemas work over there. So it still feels like MySQL, so everyone that's comfortable with MySQL is able to navigate the system without having to learn anything new. Anyone else? Yes?
You said you're running on Amazon Web Services. What type of infrastructure are you running on?
Okay. He asked what kind of infrastructure we're running in Amazon. So for the distributed MemSQL columnar database, we got the biggest memory EC2 boxes that you can get. I think right now we have 9 of them. And then there's the concept of the aggregators and the leaves. So the ones that actually do aggregation don't have to be as big. I don't remember the exact size of that, but we used the memory-heavy databases there. Our web infrastructure is all Node.js, so we just use medium EC2 boxes there. And it was a huge benefit for us because when we were trying to run Hadoop up in EC2, you run into limitations of how many terabytes of disk you can actually attach to these machines. And in Amazon EC2, conversations with the disk are all over the network. So having to do triplicate storage in Hadoop, constantly asking our Amazon account managers to up our limits on storage, attaching terabytes and terabytes of disk, it was a nightmare. So with this, I haven't even thought about disk in months, so that's quite a pleasure. And then when I actually archive things, I just stash it all in S3. So people that want to can still use EMR to do that kind of stuff, and I have long-term backups. But yeah. Anything else? All right.
Great. Thank you.
Thanks.